Okay. So to simplify each trigonometric expression, what this is referring to is like you have to do something to make this reduce, because usually in a future problem it's going to be equal to something over here that you're hoping this reduces to. So one strategy here is to rewrite as sine slash cosine. So like if it's already sine or cosine, you don't have to do anything, but like cotangent is really, do you know?
1 over tangent.
It's 1 over tangent. It's also cosine over sine, which is a little odd, but okay, we'll keep it like that. So it's sine theta plus cosine theta over sine theta.
Okay.
Cotangent's cosine. It is 1 over tangent, absolutely, but it's also this cosine over sine. So now you wouldn't necessarily know what to do, but one step is to just perform algebraic steps. So like cosine squared theta over sine theta, and you might say to yourself, well, it looks like I can combine these fractions here. So like you need a common denominator on the left, so you'd multiply the left side by sine theta, top and bottom.
Okay.
Some of this is non-obvious. Like I agree if you were like, hey, I didn't see that, because until you see it, you wouldn't know that this is true. Now you can combine the top. So you have sine squared theta plus cosine squared theta over sine theta. And maybe the top looks familiar to you. I'm not sure. You tell me if it is.
Yeah, I don't see anything.
Okay, so there are 3 trigonometric identities with squares, and this is the most useful one of them all. I'm going to snip in a picture of them. This is from the cheat sheet here. The first, it's the top one here. It's that when you have a sine squared and a cosine squared, which you have up top, that equals 1 over sine theta.
Oh.
And 1 over sine theta is cosecant theta.
Oh, okay.
Do you think you could reproduce this work? Do you think you could do this on your own? Because that's what's going to be needed on the exam tomorrow.
Yeah, I think I could do this.
Okay. All right. So let's take a look at number 2. We may apply the same strategy. In fact, we will. You're gonna rewrite, for example, secant theta is 1 over cosine theta. We already talked about cotangent theta. It's cosine theta over sine theta. So the general strategy here is to rewrite in terms of sine and cosine. So 1 over cosine theta, sine theta up top, cosine theta over sine theta. And maybe you see that like that cosine cancels that cosine, that sine cancels that sine. What are you left with?
Just the 1.
Just the 1. That's your final answer on that one.
Okay.
I like that one because yeah, after one step you kind of had your answer. You could sort of see it. The previous one you had to know to add combined fractions and things like that here. Okay. So kind of again here, you probably want to rewrite things in terms of sine and cosine, but this one's a little bit different. Like cotangent theta is it's cosine theta over sine theta.
Yeah.
And then tangent theta is sine theta over cosine theta. If you were to multiply these two together, what would that produce? Do you see that?
1.
Yes. So like this first part, if you were to multiply this in, you would get a 1 here.
Mm-hmm.
Plus, what would this be?
Oh, okay.
Cotangent squared theta. Now, if you go back to, and I'll just chat this to you. I'll send this in the chat. Oops. Why did it not do that? More chat. This is the reference sheet that I just sent to you I'm pulling most of this information from. So it's a handy reference to have. But whenever you see a sine squared, a cosine squared, whenever you see anything squared, Or if you see a 1 plus or a 1 minus, you often can use one of these identities. Do you see that 1 plus cotangent squared, which is what you have here,
Oh,
is cosecant squared? And that's your final answer for that. So
okay.
there's like a lot that like you have to, okay, like you can distribute this in. You could rewrite it and then put 1, or you could say, okay, I get that it's 1, that's cotangent squared. But then you got to know this identity. I mean, there's really like 2 lines to this. This is line 1, this is line 2, and you're done. But there's
Yeah.
all this other stuff that goes into it that maybe isn't clear.
Mhm.
Okay, number 4, starting with number 4, this next grouping of questions, these are just like the previous ones, except they tell you they tell you the end goal. They're saying on all the stuff on the left becomes 1 on the right. So you kind of have a target. It's like driving, going home, going to work. You know where you're going to school. Uh, the strategies are the same. Like on this side, secant, sine, cotangent, we're going to write these in terms of sine and cosine. That's kind of the most robust strategy. It's one that works most of the time. So we're just going to rewrite these on the left, okay, in terms of sine and cosine. We've actually already done this problem, I think. Now you draw a line here where this is. It's not like an algebra equation where you can move things around. It's an impenetrable brick wall. You're just hoping to get 1 when you're done on the left. So on the left here though, cosine cancels the cosine, sine cancels the sine. So you have 1, and you say something like done, or I mean, some instructors like QED. It doesn't really matter. Check mark, star, whatever. Just you want to indicate like these are the same when
Yeah.
you're done. That's the amount of work that's expected for a problem like this.
Okay.
Okay, so now we're going to go to number 5. All right, so whenever you see squareds, you want to refer to the identities that I keep mentioning over and over again, because that it is kind of a hint. It's like, hey, use an identity, you got squareds. What you'll notice when I pull up these identities here is that cosecant squared, if you were to substitute for cosecant squared, you get cotangent squared. And if you were to solve, you can solve these you can solve each of these identities for like something other than what it's solved for. Like this last one here, you could move the 1 over and you could say, well, cotangent squared theta is cosecant squared theta minus 1. That's totally allowed. But what you don't do is, what you rarely do is, you don't substitute in for both. Because
Yeah.
if you substitute in for both, you end up getting the same mess. So you only substitute in for 1, sub in for 1. It doesn't matter which one of identities. Do you have a preference here?
No.
So this one would be preferred for me because there's no negative in front. Negatives mean you have to distribute in. So cosecant squared is really 1 plus cotangent squared theta. So this right here becomes that minus cotangent squared theta. This is not an equation. It's kind of a proof. So you're just bringing the 1 down. But the parentheses aren't needed. So it's 1 plus cotangent squared theta minus cotangent squared theta. And those cancel. So you just get 1, 1, check mark, gold star, you're done with that. It works just as well if you were to substitute for cotangent squared theta. You just have to remember to distribute the negative to both of these on the right.
Got it.
All right, so keeping on here. Number 6. All right, so we haven't talked about this now, but you really have a choice. You can either work on the left or the right, and unfortunately, you generally choose the one that's messier or not as simplified. Uh, so like you're going to work on the left side here, but you have a
Okay.
target. You have a target at least, so that's good. But now it's like, well, what do I do? Well, we've only really talked about one strategy, maybe 2. The first one is to rewrite in terms of sine and cosine, and the second one is to use the Pythagorean identities. That's when you have squares.
Mm-hmm.
Okay, so we're going to use the first one here. So secant is really 1 over cosine theta. What is cotangent again?
It's cosine over sine.
Great. Okay. Now that trig cheat sheet that I sent you the link to, it's got those reciprocal identities on the first page in the top, I'm sorry, the second page on the top left. We're doing most of the work we're doing here today is on the second page, maybe the bottom of the first page in the lower, I'm sorry, it's mostly on the second page there in the top left. So now what does this simplify to on the left?
So it's, you get rid of the cosines and then it's 1 over sine, but 1
Right.
over sine is the secant.
So
So it
you're
works.
done. And you don't, I mean, you know, some instructors are really picky about this. I don't know what yours will want. You want to follow the models they've given in class, meaning like, do they expect you to show crossing out? Is it okay to just move, you know, is this okay? I
Okay.
don't know. I don't know. But
Yeah.
like these are hard to grade because you're sort of grading like what. Okay, so whoever gets this in the test, everyone will have the same answer because just the same steps for all of these starter proofs.
Yeah.
So just keep that in mind. 7 here is another identity. Okay. All right. You have your choice here. Do you work on the left side or the right side? Generally you would work on the left side because it's got more stuff going on. But let me go here and snip the identities. The right side is what the left's like. The left side is the right side and the right side is the left side. Okay. And what I mean by that is if you look at this second identity right here, uh, tangent squared theta, if you were to solve for tangent squared theta, tangent squared theta equals secant squared theta minus 1.
Yeah.
And you don't sub in for both. You choose a side. So if you could be done, this is done if you were to work on the right side. Because you just substitute that in there and it's the left side. Now, if you don't like that, or if you know your instructor could say, you know, work on the left side, they could demand that you know do it a certain way. That's kind of like elimination. You would have to say, okay, well, secant squared theta, this right here is really tangent squared theta plus 1 minus 1, and then you have to write one more step here to show that they cancel, but you get the same thing.
Oh, okay.
Whenever the left looks like the right or the right looks like the left, you're done. So like this is like I would actually just write done here. I mean that would be really for the instructor because it is done right here. But you could show this one step and then it's there, or you know a couple steps on the left. It's up to you.
Uh-huh.
But you're going to have to use the identities to be able to uh, you're going to have to use the identities for this.
Mhm.
Okay. So questions 8 through 11 refer to a 30, 60, 90 triangle. So we're going to draw that triangle. Actually, I'm going to grab a reference sheet and use that one. Let me grab that real quick. All right, so this is I'm going to snip this in here. Hopefully this isn't too big. Okay, so this on your right is your reference 30, 60, 90 triangle. Okay, 30, 60, 90 triangle. The short leg is across from the 30. That's the short leg. The
Mhm.
long leg is across from the 60, and the hypotenuse is the hypotenuse. Okay. Now we're supposed to figure out what the angle is for each of these problems. So we're just gonna do a few of these. Like I'm gonna look at this 30 and say, what is the sine of 30? The sine of 30 is the opposite over the hypotenuse. Do you follow that?
Yeah.
So that's x over 2x. What does that simplify to?
1/2.
1/2. Very good. How about the cosine of 30? That's the adjacent leg over the hypotenuse. The x's cancel and you get the square root of 3 over 2.
Oh, okay.
Now let's do it for 60 down here. What is the sine of 60? So the sine of 60 is the opposite over the hypotenuse. So it's x square root 3 over 2x, which is square root 3 over 2. So do you see how the cosine of 30 equals the sine of 60?
Yeah.
These two are the same. So what do you think the cosine of 60 is going to equal?
The sine of 90.
The sine of 30.
Oh.
Which is 1x over 2x, which is 1/2, because the cosine of 60 is the adjacent over the hypotenuse. So these are the same right here, and these are the same right here. Now tangent. Let's do tangent of 30. So there's a couple ways to do tangent of 30. You could do sine over cosine, or you could do it in terms of this. So 30 up here in your reference triangle, your 30 is, so it would be opposite over adjacent, which is x over x squared 3, which is 1 over square root 3. You rationalize by multiplying top and bottom over square root of 3. Okay. Now let's do the tangent of 60. Tangent of 60. So here's my 60 degree. It's the opposite, x squared root 3, over the adjacent, which is x. So notice it's just the reciprocal of the other one. The x's cancel, it's just the square root of 3.
Okay.
So these are all known to you. So in terms of like how to do this, I like they're kind of asking you to work backwards, but you should know by now that these are right from the unit circle as well. Like that's something we've talked about for sure. I don't know about in your class, but like if theta here is 60, you get square root 3 over 2 for number 8.
Oh, so the answer is just 60?
Yes.
Okay.
For number 9, the cosine of some angle is square root 3 over 2. Well, it's 30. It's right there.
Okay.
And then for this last one, to get for 11, the tangent of 60 is square root 3. All right, now the cosine theta of -1, that one's a little bit more, I don't know why they're referring to this. So on the unit circle, there are kind of 4 really nice places. Here, 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 and here. So cosine is really the x. So this position here is 1, 0, 0, 1, -1, 0, 0, -1. So where's the x value? Because that's what it said. It said cosine theta equals -1. It's really saying where is the x value -1?
0?
Well, here the x value is 1, 0 degrees. 90 degrees, this is 90 degrees, the x value is 0. At 180 degrees, or pi, the x value is -1.
Oh, okay.
Okay, and all this is referring to is that unit circle. That's on, for that reference sheet, that's on the fourth, the third page. So all that stuff we just did up here with this 30, 60, 90 triangle, it's really just the first quadrant of the unit circle. And that's what your instructor, without saying it here, is they're saying, Ella, you need to know all this stuff in the unit circle, because this right here, this square root 3 over 2, that's the cosine of 30 degrees, because cosine is the x. The 1/2 is the sine of 30 degrees. That's the y.
Yeah.
And then similarly here and here, here and here, and so on.
Okay.
Okay. Numbers 12 through 14. All right, so it's a solve each equation. Solve each equation. So we'll start with number 12. And for all of this grouping, you want to isolate the trig function. Meaning like you treat sine theta as the x and you want to solve for x. So you're going to move this, you're going to move the 2 square root 3 to the right. You're going to subtract it. So you get 4 sine theta equals minus 2 square root 3. And then you're going to divide by 4, divide by 4. So you have the sine of theta equals minus square root 3 over 2. Let me type out what this actually means. It says the sine of what angle equals minus square root 3 over 2.
Oh, well, I just have to find that on the unit circle.
Yeah, and there's going to be 2 answers. Now, if you don't have your unit circle, this is really hard. But if you have one, you'll realize, okay, my unit circle, it's here and here.
Mm-hmm.
And generally, they want these in radians. So this angle is 4 pi over 3, comma 5 pi over 3.
Got it.
And they're both correct. It's not like
You have to pick one.
you don't have to pick one. It's not a choice. It's just both. So the next question in the assignment here, it's 13. I'll rewrite it here. It's the same steps but different answers. So you're isolating the cosine theta. So cosine theta equals 1/2. So again, it's asking where on the unit circle is the x coordinate 1/2.
Oh, okay.
Oops, it's not that second one. It ends up being there and there. So you want those 2 angles. So give me those 2 angles, please.
Okay. It's pi over 3 and 5 pi over 3.
Pi over 3 and 5 over 3. I agree. Okay, and then the last one in this section, 14, it says square root 2 sine theta minus 1 equals 0. So when you add 1, divide by 2, you get sine theta equals 1 over square root of 2, but you have to rationalize. You multiply the top and bottom by square root of 2. So you get square root of 2 over 2. That's the rationalize step. So again, it's asking where on the unit circle is the y value now, because sine's the y value. Where on the unit circle is the y value? Square root 2 over 2. And it's those 2 places.
Pi over 4 and 3 pi over 4.
Okay, number
15.
15. Okay. All right, so the A is here, B is here, C is here, and so on. So the sine of A, let's do 15. The sine of A, it's the opposite over the hypotenuse. So that's 4 over 6.4. Let's do, and I would do these, I would kind of do all the A's for, they do kind of put them in order. So 16 is the secant of A. So you might know secant of A, but I would just treat it as 1 over cosine of A.
Yeah.
And cosine of A is the adjacent, which you got to be careful because of the orientation. The adjacent is over here at 5. The adjacent is 5 over the hypotenuse, which is 6.4. Whenever you have 1 over something, it just flips the fraction on the bottom, so it becomes 6.4 over 5, or you just put in your calculator and get that number out.
It's 1.28.
All right. 17, cotangent of A. So this is a lot of ways to do this. Like you said, okay, well, it's 1 over tangent of A. That's great. That's totally correct. As long as you're like, hey, tangent is, you know that one. It's opposite, which is 4 over adjacent. So 1 over 4/5, which is 5 over 4.
Okay.
Now we got to do it for C. So cosecant C. This is 1 over the sine of C. And the sine of C, we're going to a different angle now. Let me just copy this in again. I think that would be potentially useful here. So the C is over here on the left. So what's opposite to C is now 5, but the hypotenuse is still the same. So this becomes, you just flip this fraction on the bottom.
Okay.
Nineteen. Secant C. So secant of C is 1 over the cosine of C. So that's 1 over, so here's C, the cosine is A over, I'm sorry, 4 over 6.4. And then you can just flip that because it's a 1 over there. Punch that in your calculator if you need to.
$1.6.
And last one here, the tangent of C, that's opposite over adjacent. Opposite over adjacent, so that's 5 over 4. That's 1.25.
Okay.
All right, so we're up to 21 through 24. We'll probably get through all this. Assume so. All right, so this grouping of questions has it tells you the triangle is always the same, and it says that F is the right angle. So this is where if I'm a student and I got to draw the triangle, I think you do. You always want to draw the same one, whichever one you like. Like, it doesn't matter to me. It's whichever one you like. But F is the right angle, and then I'm just going to put D up here, E up here, and then for each one. So I'm just going to copy this. So when we do 21. Okay, we have to copy and record the information. Oops. We have to record the information. So it says that little e, which is across from big E, is 6, and little f, which is across from big F, is 10. And I want you to find the remaining sides and angles. So do you recall how to find the missing side?
I'm not sure.
You want to use the Pythagorean theorem. You want to use the fact that a squared plus b squared equals c squared. So this is your missing side here. 6 squared plus, we'll call it b squared, equals 10 squared. You'll do the work and you'll find that b is 8, and you'll say, well, maybe I should have known that. Well, the other option is it could be a Pythagorean triple. It could be one of these ones that works out nicely.
Mm-hmm.
Okay. So but you can always use Pythagorean theorem. Great. Okay, so that might be the only one, but we'll just assume that we can always use Pythagorean theorem. So to find angle F, we already know that that's 90 degrees. You don't have to do anything there. You might on an exam have to say the measure of angle F is 90 degrees. I don't know. You know your instructor better than I do. To find angle D and E, you want to use trigonometric identity or trigonometric functions. Like, let's just say we wanted to find D. The sine of D equals opposite over hypotenuse, 8 over 10. So D, if you're solving for D, D is equal to the sine inverse of 8 over 10. Now you want to make sure your mode is in degrees when you do this calculation in your calculator. So if you have your calculator handy, go ahead and grab it and punch that in.
Sorry, in radian or degree mode?
degrees.
Okay. Yeah, 53.13.
Great. So it says round to nearest tenth. So we got 53.1 degrees for D. What you do not want to do is use the trig identities again, because you just know that this other angle is 90 minus that one. So it's 46.9. That's very important because you want to save time on your exam. You don't want to be redoing these over and over again.
Got it.
Okay, so we're going to do 22 next. And I'm going to just copy in this picture again. So this time they tell you that little d is 10, little e is 12, and we need to find little f here. Okay, so little f, 10 squared plus 12 squared equals f squared. So grab your calculator and solve for f, please. You should get 15.6.
Yeah.
Okay, now again, you have your choice. You can solve for d or e. I'm going to solve for d. Now you can use any of the 6 trig functions that you want, but I'm going to suggest using the one that uses the known sides rather than the calculate side. Like, let's say you just made a mistake with that, you would propagate through the problem. So if you say tangent of d equals 10 over 12, because opposite over adjacent, d is equal to the tan inverse of 10 over 12. Again, you want your mode, it still is, but you want your mode to be in degrees when you're doing this. And that's 39.8.
Got it. Yeah.
So the other side, or the other angle, you get E is equal to 90 minus 39.8, which is 50.2 degrees.
Okay.
We're gonna do 24, and maybe we'll come back to 23 if we have enough time. But no, these are all exactly the same at this point. So D is 5.5, E is 2.6. So little f is found the same way. So you're going to use you're going to use Pythagorean D and E, right? D and E, yeah.
Yeah.
Okay. So you should get about 6.1. Tangent of D is 5.5 over 2.6. So D equals the tan inverse of 5.5 over 2.6. So that's 64.7. Sorry, that's D. 64.7, and then you subtract 90 minus 64.7, and you get 25.3 degrees for the other one.
Okay.
All right, so we'll move up to the top of the second page. I just need 30 seconds. I'll be right back. All right, 25 is a formula. You would need to know the formula to do this. It's usually this comes after law of sines and law of cosines, but this case they're giving you a side, an angle, and a side. So the area, when you have an SAS problem, the A has to be between the sides. The area is 1/2 AB sine C, and this is A and B are your sides, and then that's your angle between there.
Oh,
So
okay.
so this is like A, this is B, and this is this. I know I put that's your C. I hope that's not confusing later on, but it's just the numbers. 1/2 18.8 times 20.8 times the sine of 28 degrees.
Can I just put that in my calculator?
Yes, yes.
Okay.
All right, so it's 91.8. And then this one actually has units in it, so you could put meters squared if you want for that.
Okay.
All right, so now 26. The textbook doesn't say it, but you transitioned away from right triangles. These are non-right triangles.
Okay.
And there's a whole different set of like equations that govern them and how you solve them. Triangle ABC. So I always draw this triangle as the same. It's not a right triangle, so it's ABC. Measure of angle A is 45. Measure of angle C is 23 degrees. And they want you to find BC. Oh, they tell you BC is 25, but they want A to B, and that's little c. So there's two laws, law of sines, well, in math, law of sines, lots of laws, and there's law of cosines. You use law of sines when you have an angle side pair. So what I mean by that is like this 45 and this 25, they produce an angle side pair because they're across from each other.
Oh,
This C and this 23 provide an angle side pair, and they're across from each other. Now you can use law of sines to either find a side or an angle. It's used to either find a side or an angle. So when you want to find a side, as the case here, it's c over sine big C. C is the little side, big C is the angle, over, and you can use either A or B. It actually, I mean, we're kind of shortcutting all this stuff here, but it's you're using this kind of, I call it flavor of it. Um, because you know big A is 45, you know little a is 25, and you know big C is 23. So you have three of the four numbers in this case. So you have C over sine 23 equals 25 over sine 45. And then you have to solve for C. So this is a number down here, so you can just multiply both sides by it. You can multiply both sides by sine 23.
oh,
23. So C equals 25 times the sine of 23 over the sine of 45. And this is what goes in your calculator, all this. You could get a number here, and a number there, and then just multiply it out. But it works out the same. Like you don't gain or lose anything. It depends on just which way you're more comfortable with. But I really hope you've seen this before, because this is I mean, what we just did is it's a full day in the classroom of
yeah.
work. So I get 13.8
Yeah, that's what I got.
for that, and that's that.
Okay.
It's 27 here. The challenging thing is you have to draw the triangle as well. That's another part of this. The picture is not provided. A lot of geometry, trigonometry, when you don't have the picture, is much harder. So again, I tend, when it's not a right triangle, I just draw the same one, M, N, P. I start lower left, go up and down. You can do whatever you want. MN, angle N is 45 degrees, great. Little m is across from big N, that's 20. And little p is across from big P, which is 41. So this one is a law of cosines. And how do I know that? It's a law of cosines because it's side, angle, side, side, angle, side. Law of cosines can be used to either find a side or an angle. In this case, we're going to be finding this side over here, this little n. So you probably saw this in your book. It's like c squared equals a squared plus b squared minus a 2ab cosine c. You probably saw something like that.
Yeah.
So the side you're solving for is across from the angle. So in your problem c is really n. You follow
Oh,
that?
Yeah.
And that's always true. That's always true. So what are A and B? A and B are the sides around the angle, and the order doesn't matter because you're squaring them both. So it's 41 squared plus 20 squared minus 2 times 41 times 20 cosine. Well, we have n. N is, we'll put that in the next line, but n is, big N is 45. So you have everything here. You have all the numbers for this, but you have to know this is law of cosines. It's law of cosines because it's the side angle side.
Mm-hmm.
All right, now to find n, you have to get this number on the right, and you have to make sure that you square root it, because a lot of students forget that. And you can obviously square root all this stuff in here. You could do the calculation and then square root it. It's totally up to you. But that's a mistake a lot of students make. So they forget to do that. And a lot of students are uncomfortable putting all this in their calculator, but your calculator can absolutely handle all this. It's just designed for much more challenging calculations, but we sometimes forget that. So I get n is about 30.4.
Yeah, that's what I got.
Great. Right. So you have to be able to see the difference, because your instructor will not say, well, law of sine. Oh, this is law of sines problem. This is law of cosines problem. They will not say that. They should, maybe at this point, so that you know, but you probably won't get that.
Okay, so cosine is side, angle side, and then sine is what sine?
You have to have an angle side pair. They have to have an angle and a side across from each other, and another angle and side across from each other.
Okay.
But there's variations on it, and that's where we don't have enough time to go through all the different ones.
Mm-hmm.
So like 28 is law of cosines, but it's all three sides. We're not going to get through all of this. Do you want me to move on to 30, or just keep going with 28, 29?
Let's just move on.
Okay.
Most of this is just calculator stuff, so.
Okay. 30, we'll do 30 next. This is going to reference that cheat sheet I've mentioned to you. So it says verify each identity. So again, this is kind of like going back to questions 4 through 7 or 3 through 7, where you have to work on one side or the other. So you're going to work on the left side. Okay. And you maybe think, well, what do I do? I mean, like, there's nothing there to do. Well, you have to remember that there's a sum and difference formula for sine. And I'm going to snip that in. And that's on the second page of that reference sheet. Okay. And there's quite a bit that goes into this. So for example, here, this sign and this sign go together. Alpha, this is alpha. Beta is not the negative. Beta is just the pi over 2. Okay. This minus, though, minus here goes with the minus here. Those are paired up, top and bottom. So since it's minus, it becomes minus. So there's this minus out in front. We're going to deal with that. But you have sine alpha, or sine of the first thing, sine theta, cosine of the second thing. The second thing is pi over 2, just using this formula. Now it's minus because that's that one there. Cosine of the first thing, which is theta, sine of the second thing, pi over 2. Okay, and this is the right hand side's there. So now somehow this just becomes cosine theta. Okay, so now whenever it's at a nice place, cosine pi over 2, that's on the unit circle. Where is that? That's right here at the top. So that's 0, 1. Cosine is the x value. So what's the x value here?
0.
So this becomes minus sine theta times 0 minus cosine theta. What's sine of pi over 2? It's 1. What's the y value? Okay. And then, okay, well, times 0 means that goes away. This negative distributes in, and cosine theta times 1 is just cosine theta. So at the heart of this problem is, can you use the sum and difference formula? And that's kind of up to you to see if you can do that. Let's do a 34 through 36.
Okay.
We'll we'll do a 34, and then we'll probably do one of the half angle ones. So most of this is on that second page of that trig cheat sheet. So the sine of 60, it says to use a double angle formula, and you'll see here that when I snip this in, that there's a double angle formula for sine. So here's the double angle formula for sine. It says 2 theta, sine of 2 theta can be written as this over here. Well, you don't have 2 theta, you have 60. You have 60, so you're setting 60 equal to 2 theta. That's the first step. So theta is really 30, and that theta is what's over here.
Oh, and you plug that in.
Yeah, and like I know you already can probably figure out what sine of 60 is, but you're supposed to use this formula. You're supposed to say, okay, it's 2 sine 30 cosine 30. Okay, so if you have your unit circle up, we're just going to verify this real quick. The sine of 60 is square root 3 over 2. You don't have to do this in the problem, but this is how you see it. The sine of 30 is 1/2. Cosine of 30 is the square root of 3 over 2. Do you see how these cancel and you get square root 3 over 2 equals square root 3 over 2? And that's what they're asking you to do there.
Oh, okay.
So 34, 35, and 36 are all using the double angle identities. Now there's if you look on that reference sheet, there's one for sine, there's one for cosine, and there's one for tangent. I just did the one for sine. You could just as likely get the other ones. Now there's also half angle identities. So we're going to do half angle identities for the last one here. So for the last one, tangent 30, it says use a half angle. So let me go find the half angle identity for that. That's the top right on the second page for this. So it says that the tangent of theta over 2 equals plus or minus this thing over here on the right. Well, you have 30. So what is your theta? It's not 30.
60.
Theta is 60, yeah. And so half angle, you have to remember to double angle, you have to cut in half. It should be pretty straightforward. So tangent of 30 equals plus or minus the square root of 1 minus cosine. Now it's of theta, but theta is 60 over 1 plus cosine 60. So what is cosine 60? That's your unit circle again.
Cosine
The x value
is 1/2.
So that's the square root of 1 minus 1/2 over 1 plus 1/2. So it's plus or minus the square root of 1/2 over 3/2. This is no longer trig, it's just resolving fractions. So the bottoms cancel, so you get the square root of 1/3, which becomes plus or minus the square root of 1 over the square root of 3, which becomes plus or minus 1 over square root of 3. Then you rationalize, and you get plus or minus square root of 3 over 3. Now, you have to choose whether it's positive or negative. So let's go back to the original problem, the tangent of 30. Which quadrant is the tangent of 30 in? Which quadrant is 30 degrees?
The first one.
So everything is positive in the first one.
So
you would choose the positive, yeah. Okay, we didn't cover everything that may be on your test. Just say that out loud, and but we did quite a bit here. If you have the time, I would definitely redo the ones that we've already done, and if you need to, maybe you can get some help before the test from your instructor on the things we didn't quite cover today.
Yeah, it's mostly just plugging things into formulas, and he's giving us a sheet of formulas for the test. So
it is. All right, well, that's all for today. Thanks again for scheduling, and I'll see you next time.
Okay, thanks, Matt. See you next time.
You're welcome. Bye now.